I don't know what to say.
Hello.
Welcome, Adam.
Yeah.
Bring us in, man.
Yeah. So first of all, Happy New Year. I mean, we had a show last week, but we're getting back in gear and
shaking the dust off, apparently.
Clearly. And I had muted myself before, so I had to quickly push the unmute button. It's a mess. We'll get back to normal soon, I promise. Anyways, so we actually have a really fun show today. So as you can see, we have Jeremy here, who's been on the show before. Super, super cool, super awesome. I'm going to let him intro in just a moment. But we're going to be playing some video games today, and we're going to be hosting those video games on Kubernetes. So, Jeremy, why don't you kind of kick us off? Tell us what we're going to do today.
Yeah. So like you said, this is going to be a fun episode because we get to play games.
Get to see how bad I am at games. But
yeah, you and me both. I think after you reach a certain age, your dexterity starts to decline, and you can no longer play video games.
Hey, now.
Personally, well, I mean, personally, like today's controllers have way too many buttons and joysticks and things. For me, at least, it's cognitive overload. So today we're going to be running a game on Kubernetes using Agones. I'll talk about that here momentarily. For those of you who haven't seen me on the show before, my name is Jeremy Cowan. I am a container specialist at AWS, and today we're going to be showcasing a solution that I built that integrates Kubernetes with FleetIQ, which is a service that's part of GameLift, which allows you to run game servers on spot instances in a reliable way without fear of termination. So that's the topic of today's conversation.
And what I love about this topic is it incorporates so many different components. It's very real world. Like there is probably a legit game company out there that if they're not already doing this, they're thinking, man, we should definitely check this out. Yeah. You get the benefit of spot instances, which will save you gobs of money without the risk of get Gene, thank you. Yes. Without the risk of, losing your instance. And if you don't know this, it's pretty common in the gaming world for when a game starts for the players to all be co-located in the same process or on the same server. And so it's not as ephemeral as, an API might be. So we're running, if you're used to running APIs or websites or something like that using Kubernetes, then your services can come and go, and traffic can get shifted from one copy of the API to another without any issue. But with a game, no, you're like pinned to a particular server for the duration of that game. And so FleetIQ can really help with that. And then getting spot pricing is just amazing. So
it's very attractive for game studios who may be concerned about investing a lot in a game that may or may not be successful. I mean, clearly, if you are EA, you're likely to produce a game that's going to attract a lot of attention. But if you're from a smaller game studio, and you're concerned about the capital investment of hosting a game, by making use of FleetIQ and spot instances, you can lower your costs considerably.
Nice.
And yet still reliably host and run game servers without fear of interruption, because that obviously is not a good experience from the gamer standpoint. I don't want to be playing a game like World of Warcraft and then suddenly my game, shuts down. That'd be bad.
Right.
Yeah. Well, and so that's the thing, gaming companies, they want to move fast, right? They want to be able to, have rapid deployments and, take advantage of containerized technologies. But tracking state and session and managing a session. When you're in the middle of a game, if I'm playing Call of Duty, I don't, I could have my record of all time, and then for that to get cut off halfway through, it's devastating, So as people playing these games, it's so important that not only, latency is obviously important, but just keeping that state and while being able to still be agile and fast moving is super cool.
Yeah. So I have a brief presentation that walks through the solution and the various components. I thought we'd start there, and then we'll actually get to play the game.
Sweet.
So let me get this ready here. Okay. So let me start by giving you a brief description of a couple of the services that we'll be making use of here. The first is Agones, which is an open source solution for running games or game servers on Kubernetes. Of course, we have EKS, which is our managed Kubernetes service. A lot of our viewers should already be familiar with that service. You may not be familiar with FleetIQ. It's a less well-known service. As I mentioned during my introduction, it is a part of GameLift, and it allows you to make use of spot instances for running game servers. Now, there are two things that really distinguish FleetIQ from like generic spot, or using generic spot with, say, autoscaling groups. The first is its ability to fall back to on-demand when spot instances are no longer available, without having to use things like the priority expander, which is a feature of the cluster autoscaler. The other nice feature is its ability to protect spot instances from being prematurely terminated. It is constantly monitoring the viability of the spot instance pools that it draws from, and when it realizes that those instances or the instances that are provisioned from those pools are no longer viable, it will put those instances in a draining state. And with FleetIQ, you can protect that instance from being terminated until the game servers that are running have all shut down. So
it's monitoring some bit of information about the spot pool to know, how risky is this particular instance.
Exactly.
That's really cool. And then if a game is in session, it will protect that instance from being scaled in or terminated. Meanwhile, it can handle expanding the set of instances that are available if it sees the need because of availability or something.
You can use EC2 autoscaling to scale the instances in a game server group. For our purposes here, a game server group is synonymous with an autoscaling group. So you can use EC2 autoscaling to scale your instances, and there's a metric that FleetIQ and GameLift expose that allows you to scale the infrastructure based on, say, the percentage of claimed game servers. But we're not actually making use of that here in this solution. We're using the cluster autoscaler to scale the infrastructure.
Got it.
So what we've tried to do with this solution is to create a clear separation between the Agones and Kubernetes layer and the FleetIQ layer, so that as a game developer, I don't need to know about the mechanics of FleetIQ. That's handled for me as part of this solution.
That's cool.
Yeah. Okay. So the reason that this all came about was that we had several game studios approach us and tell us that they really liked the features that we were offering as part of FleetIQ, but they wanted to use it in conjunction with Agones. And at the time, there was no such solution available. And just given the extensibility of Kubernetes and the APIs that FleetIQ exposed, we decided that it was worth building this integration layer that would allow you to use the two services together.
Cool.
All right, so there are several GameLift FleetIQ concepts that are worth covering here. The first is this concept of a FleetIQ game server. And so if you were to use FleetIQ on its own without Agones, FleetIQ has this concept of a game server. That game server could actually be like an EC2 instance, or it could potentially be a container. For our purposes here, the FleetIQ game server is the instance on which the Agones game server pod is running. Okay, and this will become clear as I walk through the architecture of the solution. The other concept is this game server group, which is a collection of instances that FleetIQ manages. And as I mentioned, it's synonymous with an auto-scaling group. When you create a game server group, it actually provisions an auto-scaling group. And as part of this solution, we happen to be configuring the auto-scaling group to be part of a Kubernetes cluster. And then there's this concept of claim game server. This is a FleetIQ API, which is an API that the solution uses to protect that instance from being prematurely terminated. Ordinarily, you would use claim game server with GameLift to claim a game server that's running. And as part of that claim, FleetIQ will return like the IP address and port of that game server so that you can connect to it. But here we're simply using claim game server to protect that instance from being prematurely scaled in. Now, there are very similar concepts on the Agones side. There's this concept of a game server, which equates to a pod that's running your game. It has an extended set of metadata similar to FleetIQ. For example, it has an IP address and port that a matchmaking service would use to connect players to that game server. It has this concept of a fleet, which is effectively a collection of game server pods, and those game servers can have or can be in different states. There is well, like when you first start a game server, it's in a ready state, and then you can call an API, an Agones API, to allocate that game server. And then similarly, when the game is finished, you'll want to shut down that game server, effectively marking it as no longer available to that matchmaking service. And then Agones has its own capabilities around auto-scaling. I'm not really making use of the Fleet autoscaler here. Agones has like a de facto autoscaler that you can use, or you can write your own. But it's really unopinionated as to how you scale your game servers. And then lastly, we have the Kubernetes cluster autoscaler, which is what we're using to scale the infrastructure on which our game servers are running.
So a game server, an Agones game server, is a Kubernetes pod?
Yes, that's correct.
And then do we limit, or does it limit itself, or does Agones limit those pods to like one per EC2 instance?
No, not necessarily. So you can run as many game server pods on an instance as you can, or as the instance will support. Generally speaking, with multiplayer games, you want to allocate like a vCPU for each player. So obviously, that's going to limit how many game servers you can actually run on an instance. But they're really, I mean, it depends on the size of the instance. If you only wanted to run one game server on an instance, you could, but you also have the ability to run multiple game server pods.
Well, I think I'm starting to understand now that, okay, so you might have 2, 3, 4, 5 game servers running on an instance, and as soon as that instance is marked as okay, we're done with this instance, it's time to swap it out or do whatever with it, those games will get the instance will probably, in Kubernetes terms, would probably be marked as cordoned.
That's right.
And then so we wouldn't schedule any new games on them, but the ones that are running would get the opportunity to complete, right?
That's correct. That's correct.
Okay.
Yeah, and I think this will become clearer as I step through the architecture. I have a slide a little later in the presentation that goes through how the solution works.
Okay.
But I thought it was important to introduce at least a few of the basic concepts that the solution is making use of here. So in this illustration, we're attempting to show the different FleetIQ APIs that we're making use of. As you can see, FleetIQ runs a set of algorithms to determine the viability of the instances that it has provisioned as part of that game server group. And our solution, which runs, part of it runs as a daemon set, makes use of these different APIs like register game server, update game server, and deregister game server, along with claim game server, to register the instance with FleetIQ, to continually update its health, so that FleetIQ knows that it's being utilized, and to claim that game server when on startup, essentially, and protect that instance from being scaled in so long as, or for as long as, there are allocated game servers running on that instance. And then finally, when the last allocated game server has shut down, deregister that instance from FleetIQ, allowing FleetIQ to reclaim that instance. So hopefully that makes sense, or it's beginning to make sense.
Yeah.
The three different components that the service is comprised of includes this daemon set, which I was talking about. An instance of this daemon set runs on each game server instance or FleetIQ instance within the cluster. And as I mentioned, it will register the instance with FleetIQ and claim it so that it's not prematurely terminated. It's also calling describe game server instance, or actually it's making a call to Redis to get the state of the instance. For example, earlier I talked about how when the instance is no longer deemed viable by FleetIQ, FleetIQ will put that instance in a draining state. The daemon set actually monitors a Redis channel to determine whether it's still viable. When an instance is put into a draining state, it will cordon the instance so that new game servers, new Agones game servers, are no longer able to be provisioned onto that instance. It will also drain that instance of all unallocated game servers, forcing them to get rescheduled onto other instances in the cluster. the allocated game servers that are running on those instances will continue to run until they're shut down. And so this way, those unallocated game servers, or those game servers that are not currently hosting players, are rescheduled onto other instances within the cluster.
That's
now,
really cool.
Yeah. Now this other component, this pub sub service, is essentially it's essentially calling describe game servers and getting the state of the game server according to FleetIQ. For example, whether it's running or currently in a draining state or terminating and so forth. And it's publishing that to a channel. We're creating channels for each instance that gets provisioned within the cluster. And the daemon set is subscribing to the channel for the instance on which it's running. So think of it as like an SNS topic for each instance, and the daemon set is subscribed to the topic for the instance that it's running on. And then lastly, we have a Redis cluster. Now, the solution is flexible enough that you can either run Redis within the cluster, or you can actually make use of Elasticache.
Nice.
And I think I've walked through the replacement process. We'll actually have a look at this when we get to the demonstration. So I don't think I'll step through all of this here. I'll explain it as we're doing it. And similarly, I'll describe the scaling process. So let's get to the game.
Yeah.
Okay. So Brent and Adam, do you want to start playing your game? I think you might already be in a session.
Yeah. Let me get the layout set up.
And to set the context here, Jeremy, correct me if I'm wrong, but Brett and I are going to actively play in this game, which we're going to do some racing here, and walk us through like what's going to happen as we're playing.
Yeah. So because I don't have a way of forcing an instance to be put into a draining state, I'm going to change the configuration of the game server group by modifying the instance types, the preferred instance types that it's going to use. So I think it's currently, let me see. Let me open my terminal here. And I'm going to run a command here. I'm going to describe the game server group, and it's going to tell me which instances I've configured the game server group to work with. Okay, so it's currently configured to work with C5x large and C4x large. And if I look at the nodes in this cluster, this is the instance on which the game servers are running, and this is a C5x large. Okay. Hopefully you can see that. So what I'm going to do is, as you're playing the game, I'm going to change the configuration of the game server group, which is going to cause FleetIQ to replace the instances in the game server group with the new set of instances. However, because you and Brent are actively playing the game and the game server is in an allocated state, that instance should be protected from termination. So what we should see is that when I replace or when I change the configuration, the instance will be cordoned, and the non-allocated game servers will be rescheduled onto another instance within the cluster, which has yet to be provisioned.
So we'll see a new instance type come up.
A new instance type of, say, like M4x large or M5x large.
And then the unallocated game servers will move over to them.
That's right.
But ours won't. And then our instance will continue to stay up and run because we're in the middle of a game.
That's right.
That makes sense. That's awesome.
Yeah.
Fantastic.
So we're going to go to a layout that we don't normally use here on the show. And we don't have a ton of control over it, unfortunately, but you can see the screen, Jeremy's screen share, so we can watch, what's happening there. And then you can see us playing the game. And Why Is Bob Not Allowed wants to take bets, but Adam and I have already played head-to-head once or twice, and I can tell you we would have to set odds. So I would need like a 10-minute head start.
I've played a lot of like Mario Kart with my kids, and I'm, what can I say?
Yeah. That's definitely why.
So
right.
so incidentally, for those folks who are watching, we're playing a game called Super Tux Kart, and it's I believe it's an open source multiplayer game. This happens to be a racing game that we're using to showcase the solution that we built.
Nice.
Yeah.
All right.
So it's pretty awesome that I'm on the clock right now and I'm playing games. All right. So you got to pick the character. I don't know why this is taking me so long. All right. And just choose a level. Okay. And we're going to start racing.
I want to know, why would anyone ever want to drive in reverse? Or maybe I should make Adam drive in reverse.
No, it's just the map gets reversed.
Oh, okay. I'm like, what? That doesn't even make. Oh, look. Did I pick this?
I may have. We've been testing on a golf course one, so. Oh, you chose the same character. That's funny.
Okay. All right. So the two of you are playing the game.
Yep.
I am going to execute the command to change the underlying instances.
Man appeal.
How are you going? Whoops. How are you going faster than me?
Oops.
Oh, you know what? I'm going to race you in reverse.
Fine.
All right. There we go.
Need to make a small change. Keep playing.
Okay.
Okay, so I changed the configuration of the game server group, and probably in the next 30 seconds or so, we'll see that the instance is put into the instance will be cordoned, and the non-allocated game server pods will be put into a pending state, waiting for a new instance to be provisioned.
So our game is good right now, no problems. We're still actively racing.
Okay.
Adam's getting a little violent.
I like this one. So, all right, maybe I should go faster so we get 4 laps.
It's very scenic. Okay, so now I see a message saying that scheduling is disabled. And if I come over here, look at what's happening.
Brett followed me on the shortcut.
So if you can see my screen, you'll see that the non-allocated game servers are currently being terminated. And those will get rescheduled onto this new instance that is being provisioned here. It's not currently in a ready state, but it should be in a moment. Now, if we look at the pod that you're using here for the game, I'm going to come down here. Let me find your game. I believe this is it. But actually, what I want is I want to look at the daemon set logs. So let me come back over here.
Brent, should we just maybe go to Jeremy's screen, full screen for a bit?
Sure.
Yeah.
But let's stay in the game.
Yeah. Oh yeah. I'm not leaving.
You can stay in the game. So hopefully you can see the logs here. So this is running a loop, and you'll see that the instance is active here, and then on the next the next check, the instance is currently in a draining state, which means that the instance is no longer viable. When that happens, the node is cordoned so that no new game servers can be scheduled onto this instance. And it's updating the game server pod that the two of you are using with a particular toleration. And then the node is tainted. And the reason that we add this toleration is so that it can tolerate the taint that we add to the node. And that allows the game server pod to continue running on the instance. The other pods, the non-allocated game server pods, don't have the toleration, so those get evicted.
So that sounds like it's not just an at-scheduling decision. It's constantly being reevaluated?
Every minute, once a minute.
Interesting. That's cool.
Once a minute. Yeah. And so it checks every minute, and then it prints its status. So is coordinate is true, so the instance is currently cordoned. Is ready for shutdown is false because there's still an allocated game server running on this instance. And is waiting for shutdown or is waiting for termination is also false because there are active game servers running on this instance. And so the daemon set will continue to update the game server health, which will protect that instance from scale in until we shut down the game server pod.
Nice.
So actually, why don't we do that? The two of you are still playing the game, but I'll come over here.
All good things must come to an end.
All good things must come to an end. Yes. Also, actually, before I shut down the game server pod, let me also show you the logs from the pub sub component that runs in the cluster. So here it is, and we'll look at its logs. And so you'll see that it. Well, this is not very interesting, but it's publishing the state for the instance on a separate channel. You see there's a channel for each instance in the cluster, like here's I0894, here's I07FB58, blah, 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 and so forth. And so it publishes this status once a minute.
And then the daemon set is the subscriber?
That's exactly right.
Awesome. That makes sense.
Yep. Okay, so let me shut down your game server pod. I will exec into this pod, and I will.
Now, granted, if I were a game developer, I wouldn't be execing into a pod. I'd have some sort of logic.
That's right, right, exactly. So if you were a game server developer and you were using the Agones API, your matchmaking service or the game itself would call this API to shut down the game server when the players left the game or when the game was finished. So I'm only doing this for demonstration purposes. You would not do this in real life. Okay. So I'm going to run this curl command, which simulates calling that shutdown API, and I'll come over here to the GameLift daemon set, and on the next run, it should say that there are 0 allocated game servers running on this instance, and it should be ready for shutdown after that. So let's give it a moment here. And I'm happy to answer any questions if there are questions in the queue, or if the two of you have any questions about the solution and how it works.
No, I think this all makes sense. What I love about it is just how like integrated with the notion of game servers. It is, instead of it being, because I mean these are all constructs that exist elsewhere, coordinating, preserving this instance because it's running a piece of it's running some work that we want to let finish and all that stuff. But like this being specific to game servers is really cool.
Yep. Yep. And here, actually, while we were talking, you'll see that it says there are 0 allocated game servers running on this instance. The instance got deregistered from FleetIQ, and you'll see that this was also updated. So is coordinate true, is ready shutdown is true, is waiting for termination is currently false, but that should change here momentarily. It's skipping the health check because it doesn't need to protect that instance from termination because there are no longer allocated game servers running on it. And eventually, probably within the next few minutes, this instance will be terminated.
So 76.122, we'll watch for that to go away.
Yeah.
This is cool. Is this, yeah, I mean, I like, I don't even know what to ask.
Well, so I'm curious to hear more about, I guess what you're seeing out there with Agones. Like, are we seeing more adoption of Agones and the integration with FleetIQ? Like, are you starting to see customers test this out and play with it?
So Agones is definitely growing in popularity. I think game studios are looking for efficient ways to run games, and containers gives them a really nice vehicle for doing that. Agones also provides a whole framework for running containerized game servers, and we are beginning to hear from customers who are interested in using Agones with FleetIQ. This solution is currently in a closed beta. We are working on open sourcing the solution now to make it broadly available to customers. But we have probably a dozen studios who are evaluating this solution now.
Nice. So help me understand by telling me the flip side of this. Let's say that you have Kubernetes and you have Agones, but you don't have FleetIQ.
Mm-hmm.
Where does, what would the game company do in that particular instance? Where does the automation and functionality stop?
Yeah, so ASG recently released a new feature called EC2 Instance Rebalance or Rebalancing, which will send you an early warning signal when a particular spot pool is no longer viable. And in that way, it's very similar to FleetIQ. The difference is that that rebalancing recommendation doesn't provide any sort of protection from termination. And it doesn't have the ability to fall back on demand when there are no spot instances available. That's what's nice about FleetIQ. You could do all of this with the EC2 spot rebalancing recommendation, or a large portion of this, but you'd be missing the key component, which really allows you to run game servers on spot instances, which is that temporary protection from termination. Nice. Now, you do pay a small uplift for FleetIQ, but it's still substantially less than on demand.
So, like, pure native spot pricing is up to 90% discount, and I'm guessing then FleetIQ is something that's up to slightly less than that.
Yes,
that's the way it works. So it's still a massive discount, but just a slightly less massive discount.
Yes, slightly less massive. Yeah,
I like that.
Yeah.
So Texan Raj wants to know, by the way, welcome Texan Raj. I wonder, I forget where you live in Texas, but we got snow in Texas, by the way, Adam. So don't be jealous.
So jealous. Oh man.
Oh, Houston. I'm guessing you didn't get snow then. But he wants to know, is there a GitHub site for this project? It looks like cool stuff.
So not yet. The project will be called Syntasmos, which is a Greek word for connector. I will be sure that we send you the link once it's open sourced. We're currently in closed beta now, and you can. I mean, if you're interested in trialing the solution, you can contact me directly. Hopefully, you can put either my email address or my Twitter handle on there, and you can send me a tweet or an email registering your interest in the solution. But we should be open sourcing this probably within the next couple of weeks if you can wait that long.
Perfect. And we'll add, for the future viewers of this video, we'll add, once it is open, we'll add the link to it in the comments section.
Great. Also, I just want to show you that that instance. Let me reload my screen here. Okay.
Yeah, I saw the instance had gone away, and if I remember right, it was like 76,122.
Yeah,
sounds right.
And that's now gone.
It's now gone, and it's been replaced by this this other instance here, and we should see three game servers running on it. Nice.
That's awesome. Yeah, and that one's only been up for like 10 or 12 minutes.
That's right, 12 minutes, yeah.
Perfect. FPS Monkey says, can FleetIQ integrate reserved instances with spot demand so that there's a floor to the number of servers available for the pods to take advantage of?
No, but you can create another you can create another node group of on-demand instances, which you could use as a fallback.
Yeah, and it sounds like with FleetIQ there is some, I hate to say this, intelligence, built in. So with, I'm assuming that like with any spot request, the more diversity that you can put into your request, the better chances of having your request filled.
That's right. So you should definitely diversify your game server group and use a mix of different instance types. However, you need to be cognizant that we are using the cluster autoscaler, and the cluster autoscaler was not really designed to work with mixed types. So all of the types that you use in your autoscaler group should have similar amounts of CPU and memory. You'll notice, like when I configured my game server group, I'm using like M4X large, M5X large, so different generations of the same, roughly the same size. And you could do that. You could diversify by using like M and C and R and so forth,
right.
But they should all have similar amounts of CPU and memory.
That makes sense. Avasia wants to know, if a user opens up multiple games on their computer, will there be multiple nodes running? Is there a way to limit the number of connections from a user so that they do not try to overload the system?
There's nothing inherent in the solution that does that. You have, so this system is designed to automatically scale, or it can be configured to automatically scale. So you could use the Agones fleet autoscaler to scale the fleet of game server pods. You can use the cluster autoscaler to scale your cluster. So if you're making use of those sorts of things, your cluster really shouldn't get overwhelmed, and you should size your instances so that you can handle as many game server sessions as the instance is capable of, without overloading the instance.
Yeah, and that sounds like that question sounds like a mechanism. It's asking about a mechanism that would need to exist no matter what your underlying compute looks like. You'd need to be able to rate limit or something the number of connections from a particular client.
Yeah.
But what I like about this is, and Adam, chime in if you want to about other examples, but we see other examples in other industries where essentially we're taking what used to be compute, just plain old instances or plain old servers, and they're being moved up a level to containers. And then what's below, where the containers are executing, are starting to just get treated more generically. So, this is just a compute resource now, and we can swap it out from underneath these pods whenever it's convenient and to meet whatever our goals happen to be. So if we want to save money, we can use Spot, and GameLift can help us do that. We can swap in whatever the most appropriate instance is. Meanwhile, we keep our game server at this higher level of the stack inside a pod. So that's really cool.
Yeah, well said.
So Texan Raj wants to know, will this run on Bottle Rocket?
That is a good question. It should. I mean,
why wouldn't?
Yeah. I mean, we're making use of native Kubernetes constructs here, like daemon sets and pods and so forth. So no, I mean, there's no reason why it wouldn't. At least I can't think of a reason why it wouldn't.
Yeah, I can't think of anything that you went over today that runs like at the OS level. Everything is in a container, getting scheduled by either the Kubernetes schedule or the Agones scheduler. So yeah, it seems like my first reaction would be, yeah, it should work.
Yeah.
Cool. Well, if there are any other questions, throw them in chat. If you want to reach out to Jeremy, how can we reach you?
So I can be reached at JICowan on Twitter, if that's your preferred medium. Or you can send me an email at jicowan@amazon.com.
Nice. Perfect. And so yeah, reach out to Jeremy if you have any questions, or obviously you can reach out to Adam or me, and we'll do our best to get them answered. And chances are pretty good that for this, we'll just reach out to Jeremy ourselves.
That's exactly it.
Sounds good. Yeah.
We're just the intermediary until it gets to him.
Exactly. All right.
So I just want to say before we wrap up, we do have an additional couple days of reInvent Part 2.
Oh yeah, that's right.
Right. So this, I believe it's the 12th through the 14th, and today's the 11th. So Tuesday, starting tomorrow, and there's a couple talks. I mean, there's quite a few talks, but I have one running ECS at scale. So check it out. Also, Justin Garrison has a talk with Disney Plus with Disney on running Disney Plus on ECS at scale. So that's going to be a super cool one. Jeremy, anything you have going on during the Part 2?
No, I think I have a few executive briefings scheduled, but no talks. My talk was last year. I did a talk on container security or security best practices, which I think is available on demand now. So
very cool. Feels like so long ago.
I know.
It does. Yeah.
Crazy. Anyway,
Awesome.
Just wanted to share that.
Yeah, thank you. I'd forgotten, so I appreciate that. All right. If there's nothing else, I will see you guys around. And if you're out there in the audience watching this after the fact, and you have questions, feel free to reach out.
Yeah, thanks.
Cool.
Thanks for having me on.
Jeremy, thanks, man.